Part of the session, I'm going to talk about smart contracts and to explain you what a smart contract means and how it is used in a blockchain network. Okay, so to explain you in simple words what blockchain, what a smart contract refers to in a blockchain is a smart contract is a automated piece of software. It is a small smart contract, as the name suggests, it's a contract first of all. And the reason why it is called as smart is because it can automatically execute the contract based upon certain predefined conditions or events. So in terms of computing or a programming terminology, if the simplest way to represent a smart contract is a if then else or if else kind of a logic. So if something happens, then do something. Yeah, so that kind of a logic is included in the is covered in the smart contract. Just give me 1 second. Okay, so a business rule can be included in a contract, and the business rule is written in such a way that ideally it should be automatically executed, which means the software that we have written on the blockchain will receive inputs through some mechanism. Yep, it could be through a sensor that notifies about certain state of the software or of the environment in which a blockchain is being run, or something or the other, something automatic, maybe an event detected using a CCTV camera that can take an action. So those kind of automated actions help to generate events that can be identified by the smart contract, and once the event is verified, it will be executed, or the smart contract will be executed. So smart contract is embedded in the blockchain and executed with the transaction. So when you're executing a blockchain, when you're executing a smart contract, the request for executing a smart contract is sent via a transaction on the respective blockchain. The transaction, like any other transaction in a blockchain, is verified and it is signed. And it is typically encoded in whichever programming language the blockchain is using. For example, if it is Ethereum, then Solidity is the programming language that is used to write the smart contracts. If it is Hyperledger, then it is chain code. So like that, different platforms have different languages they can use. So smart contracts are autonomous because they, like I said, they act based upon an external event, which is captured by the software system. And it is accurate because the logic for the smart contract or the action that it has to take is already recorded or secured, encoded in the smart contract. It is secure and trustworthy. Secure because it is on a blockchain, and I have already explained the security features of blockchain. And it is trustworthy and unbiased because the reason why it is unbiased is the action that the smart contract has to take is already predefined in the logic. So there is no human bias that can be introduced when a decision has to be made using a smart contract. Okay, so that's why, because it is unbiased, it also becomes trustworthy. It is very much faster. Like I already gave you an example of how a bricklayer can get paid when the when the drone and the machine learning algorithm detect that the brickwork is completed. So automatic and faster payments can happen, and this reduces the human effort required. So it reduces the cost as well. Examples I have already given you, so I'll skip this. Now let's get into some real examples so you can see the power of blockchain. So this is an example of using sensors for site compliance on a construction facility, right? So here you can see there is a crane here, there is a drone, there is a sensor which is sending some information, which is sensing some information and sending that information. There is a mobile phone also sending some information. There is an equipment on site which is also sending, and there is a temperature or thermometer that is all sending information. So consider this as a setup on a construction site. One thing, so anything that is happening in this area, right? All this information is automatically generated using sensors. So there is no human involvement here. This sensor sends information and it is added to the blockchain using the blockchain and smart contracts. Okay, so what could be an example of a smart contract here? The smart contract could be checking the temperature on the site. And as per maybe some government regulations, if the weather becomes extremely hot, maybe above 45 or 48 degrees, then the work should stop on the site, right? So let's assume this sensor, which is a temperature sensor here, is measuring the temperature on site. If it is continuously measuring the temperature and sending it to the blockchain, so the blockchain is keep recording the temperature on site at a given interval. It may be 10 minutes, it may be half an hour or an hourly rate, whatever is programmed. When this information is sent, the information on the blockchain, in fact, is received by a smart contract. Yeah. So smart contract picks up the information and it tells, okay, put this on the chain. That could be the simple logic that a smart contract is designed to do. Another thing that a smart contract may be programmed to do is to check the temperature. And if the temperature is above 50 degrees, yeah, then do something else. And what could that be? That could be notifying the site supervisor that the external temperature is above 50 degrees and it is the time to stop work. So this process of automatically collecting the temperature and notifying the site supervisor, or even sending a message to the employees who are working on site on their phone, or if they have any other communication device, notifying them that it is time to stop and go under a shelter. Right? So this is very important from occupational health and safety perspective. So if, for example, this system is not there and the temperature rises above 50 degrees, becomes 51, 52, 55 degrees, and somebody gets a heat stroke and they get severely ill, they have to hospitalize, then the liability goes to the construction company, because it is their responsibility to maintain and provide a safe working environment for the employees on site. Yeah. So how is blockchain useful here? Blockchain is useful for two reasons. One is we are continuously capturing information from this sensor, right? So there is an immutable record on the blockchain saying that at 10 o'clock, the temperature was 42 degrees. At 12 o'clock, the temperature went up to 45 degrees. And at 2 o'clock, the temperature peaked above 50 degrees. And when the temperature went above 50 degrees, a smart contract automatically fired a transaction notifying the site supervisor to stop the work on site and ask all employees to go undercover. So there is evidence for the construction company that they have taken all possible measures to look after their employees. Okay. So, and all that evidence is immutable, it is tamper-proof, and it is recorded in real time on a blockchain. So if later, say the government department who looks after the laborers comes to the site, they can be provided with this complete transparent information, using which they can take any appropriate action that is required. Another example of how a smart contract can be used is to govern site working hours, registration, and payment system. So this is very simple use case. Whenever an employee comes, even we do it now as well on site or in companies. When you enter a company, you kind of scan your ID card, which is the RFID sensor inside. That records the time that you have arrived at your work. And when you finish your work, you again clock out or you scan the card and then you leave. So the system is identifying how much time you have spent at work. And if it is an hourly rate that the employees have to be paid, which is typically the case here in Australia, then the system can figure out how many hours they worked. It can use some other technology to verify that the work that they have to do has been done, is completed. And the moment they scan or tap their card again and leave the site, the backend technologies can fire up, and they will see, okay, this employee was supposed to do these 5 things. Let me check if the camera in this room where he was supposed to work, has he completed the work that he or she was assigned to do. Combined with AI and machine learning, the answer could be yes, no, or maybe. And according to the output that you get from these software algorithms, you can then go and process the payment in real time. So it could be as quickly as the moment you tag out, the systems work in the background, and you are get paid maybe in the next 30 minutes or in an hour. So that is another example of how smart contract can be used for managing attendance and issuing payments. All right, this is another example from a procurement case where we are procuring raw materials that go from the main raw material provider to the factory, to the retailer, and to the construction site. So the whole, this is more important from a provenance perspective. Like earlier I mentioned, the provenance of building materials. Where did the building material come from? Yeah, so we need to have a record or proof of where the building material was sourced and whether it is the real material or not. Or sometimes there can be some form of counterfeit. People may swap the real products with the fake products, or some things like that can happen. So to prevent that, this system, smart contracts, can also be used on blockchain at each and every stage in the supply chain. Whenever a change of asset is happening from one party to the other, right? At that time, we can integrate other technologies to detect activities in real time and invoke smart contracts to execute and record such information on the blockchain. Okay, this is a use case from India. This is for Tata Steel. So blockchain is there in India in many different applications and across different industries. So this is a construction case for Tata Steel. And what they have done here is, if you can see this here, this is called as a I-beam. It is called, because it looks like an eye. It is a steel beam used in construction, and it has an eye shape. So this is called I-beam. This is a structural component in construction. So it is very important because for some reason, if the building collapses or something is wrong, we need to know that the product that was gone in the construction of that building was up to the mark, right? So in this scenario, there is a complete history of the whole production of this I-beam. Yeah. So all the suppliers, first of all, each I-beam has its own unique ID. So each metal beam, each steel beam, this one has a unique number. So it cannot be replicated. Either it could be kind of pressed or embossed on the steel, on that beam itself, or there could be some form of a sensor that we can attach to it, or a QR code, or some form of identification is there. That identification is then linked to all the suppliers in the supply chain. right? So it could be the supplier who supplied the metal, the steel to manufacture this. It could be the supplier who provided the mold for making the I-beam, and all the suppliers. The complete provenance, complete history of the suppliers is the complete history of the suppliers is available. Next, fabrication specification. So I told you the mold that was used to build, to manufacture this. So there are proper fabrication specifications. What that means is how was this fabricated or manufactured? Those details, those documents, those designs, those criteria, they are all also uploaded on the blockchain. Similarly, design and construction specification, transportation details, all this information that is related to a particular beam, steel beam or I-beam is recorded on the blockchain. So you have a full end-to-end traceability. So if anything goes wrong, you have all the information required to make your case. And finally, it also captures the carbon footprint. And what that means is how much carbon was generated in this manufacturing process. And this is important because of the ESG that I mentioned to you earlier, that companies are now becoming or now have to become more environmental conscious because of the impact that their manufacturing activities have on our planet. So this is a very good example because you can see in real that and also an Indian use case. Okay, so that was all about smart contracts and 4 examples that I gave you to. So I hope you have a fairly good understanding of how smart contracts work. If there are any questions, we can always discuss that in the tutorial later. The next bit that I want to talk about is another concept within blockchain, which is called as non-fungible tokens, or you might know these as NFTs. Okay. So what is an NFT? NFT are blockchain-based units of value or tokens with a unique ID linked to an underlying asset. So you have a digital asset and we want to assign a unique ID to that asset, and that unique ID is a token. Yeah, so the token, let's just imagine that a token is a number that we are giving to a physical, a virtual asset. And that token in this form is called as a non-fungible token or an NFT. And what is the meaning of non-fungible token? So what is the meaning of non-fungible token? Non-fungible means something that cannot disappear or cannot change. There are fungible tokens as well as non-fungible tokens. So non-fungible token, the identity is not lost when the token is exchanged. So if I have an NFT which has a unique ID, I sell it to you or I trade it with you, you get that NFT. Yeah, you get that asset with that unique ID. You do not get another copy of it. You get the actual one. To put it in context or to give you an analogy of what an NFT is versus what a fungible token is, if I have a note, like a currency note, right? A currency note has a unique number on it, right? So let's imagine that is an NFT. Okay. So I give you that note, right? You have that same note because the ID, the number is on there. So it does not change, right? So the identity travels from me to you. The currency note with a specific serial number is with you now. Okay. Before it was with me. So I have given it to you. In exchange, you have given me, maybe you have sold me some product, right? So asset exchange happens and I give you money, you give me a product. Now let's assume instead of a note, I give you coins, right? 5 rupee, 10 rupee coins, $1, $2 coins. So typically coins do not have a unique number on it. in most countries, coins do not have a number, but notes have a unique number. So when I give you a coin, and you mix it in a jar with other coins, you cannot figure out which coin I gave you because there is no ID associated with that. Okay. Whereas when I give you a note and you record the note number, and even if you mix it, you can always find out which note I gave you because you have that number. So a coin is a fungible token and a note is a non-fungible token. Okay. So that analogy, I hope will be helpful for you to understand the difference between fungible and non-fungible tokens. But in the context of this session, our focus is on non-fungible tokens. And the reason is we want to keep track of assets, right? On the on the construction side, there may be many different types of assets on it, right? It could be a cement machine, it could be a bricklaying machine, it could be a lot of different things. Every asset has to have a asset ID, a unique asset ID, and in this case could be done using a NFT. All right. Another example of NFT in a virtual world could be photographs, could be artwork. Each and every artwork has a unique asset ID. Yeah, unique ID, that is a NFT. And NFTs can then be used to trade or exchange for different services. Smart contracts use NFTs to take specific actions on selected assets. So if I have to assign something to a specific asset, maybe a history that this machine was serviced on this and this date. So I can program the smart contract to say that this NFT was serviced by this person who also has a unique ID. So all that information is collected on a blockchain. What could be some examples of NFTs in the business context other than the images or the artwork that I mentioned? PDF document could be an NFT, warranty documents, service agreements, bill of materials, even a building on its own can be an NFT because it is an identity that we are assigning to that whole structure. Okay, so NFTs are also an important aspect in the blockchain. All right, so I think that is all I wanted to cover in today's lecture. So it has taken a little bit longer than what I had planned for. But yeah, so that concludes the lecture part. We can now start the tutorial. So for tutorial, what I will do is I will upload these slides on the Google Drive that we used yesterday. And you can have a look at the look at the slides. And for the tutorial, what I have done is I have made 20 questions. Some are fairly like easy questions like fill in the blanks, and others are where you have to find the answers. And most of the answers you will get from the lecture slides that I will share with you now. So let me take a break to give you the slides. You can download it, and then I will open the tutorial task sheet, tutorial slides as well, so you can see the questions. And then we will go through each and every question because it is there are 20 questions, and I can answer them. You can answer them first, and then we can discuss those answers. We will use the same Google Doc that we used yesterday to record the answers to the tutorial questions. Okay, so I'll stop my screen sharing now, and then I will send you the Google Docs. The lecture slides. So give me a minute to Okay, I have uploaded this tutorial sheet on the Google Drive as well. So please download both the lecture slides as well as the tutorial task, and go through these tasks. There are 20 questions that I have listed, and it will probably take you, say, 30 minutes or 35 minutes, because it is very key concepts that I have covered there. It will be easier for you to find answers to those either from the lecture notes that I have, or you may have to search online. So let's take 30 minutes to work on these answers, and then we can then I will discuss all the answers to these tutorial activities. But before that, if you have any questions, then please let me know. We can answer any of your doubts that you may have on the topic that I have covered today. It was a fair bit of work, a fair bit of knowledge to capture and to process, because it's a completely new technology for you, and I've tried to cover the major portions of it today. So let me know if you have any questions. I'm here and I can answer your questions. Okay, I think you have completed the tutorial tasks. I've seen most of you have got the answers there. So let's go through the questions one by one, and then I can share the discuss the answers with you all. Okay, so the first the first question that I had was, blockchain is a peer-to-peer dash distributed ledger technology that makes the record of any digital asset transparent and unchangeable. So the answer to that is, let me see what all you have got first. So most of you have, those who have replied have got it correct. The answer is decentralized. Okay, so the answer for this is blockchain is a peer-to-peer decentralized distributed ledger technology. So decentralized is, it's decentralized because it is decentralized because there is no single entity in control of the blockchain network. Yeah, so it is a decentralized network, and that is the core feature of blockchain. The next question that I had was, blockchain networks are much dash and deal with no real single point of failure. There are a few options for you to choose: simpler, easier to scale, convenient, and faster. So the answer to this is easier to scale. So blockchain networks are much more easier to scale and deal with no single point of failure. The next question is Bitcoin an application of blockchain technology? True or false? So let me see what all you had got. So true, 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 and true. So all of you have got it correct. It is true. In the context of blockchain, what does P2P stand for? Okay, so I think there was an answer already in the previous question. So if you have seen this, blockchain is a peer-to-peer, right? So P2P stands for peer-to-peer. List 3 types of blockchains. Let me see what answers you have got. So so one answer is private, consortium, and hybrid. Who else has got another answer? Public, private, and consortium. Private, hybrid, and consortium. Public, private, and consortium. Okay, so I think it could be a mix. So public and private are definitely 2 different categories. Consortium is the 3rd category, and a hybrid could be considered as a mix of both. So sometimes you have some public aspect and some private aspect. So in fact, you can have 4 types based upon the answers that you have got here: public, private, hybrid, and consortium. Consortium blockchain, I have not covered it in the lecture, but I can explain you now. Consortium blockchain is where different companies that are part of a same business kind of come together and build a blockchain, because they can share the common information that they need for their business operation. So in one of the slides today, I showed you the construction business, the construction blockchain, building and construction blockchain, where there was insurance and suppliers and traders and all those people, entities there. So that is an example of a consortium blockchain. Another example for a consortium blockchain could be, say, for example, a vehicle, like a car manufacturer, right? So a car manufacturer, if as a business, involves a number of other businesses as part of it. It could be their suppliers, it could be the insurance, it could be the government the department that issues licenses, it could be maybe the spare parts manufacturers or the service stations where you get your car service. So all those companies can form a consortium, and a consortium blockchain helps to address that aspect. List 2 private blockchains and 2 public blockchains. Let me see what answers you have. Private blockchain, Hyperledger Fabric is a good answer. Yeah, that's right. IBM has IBM Food Chain. That could be an example of a private blockchain. Ethereum is public. That is right. Bitcoin is a public blockchain. Corda is a private. Bitcoin, Ethereum, Solana. Binance, yeah. So we have done some work on Binance blockchain as well. If you want to check out this company, NICHO NFT. So Vipin, I have listed that in your answer. Nicho NFT is a NFT platform that we have built that uses a Binance Smart Chain. Bitcoin, Ethereum, Hyperledger, Cardano. Okay. Yeah, so I think most of you have got it correct. Who is the founder of Bitcoin? Satoshi Nakamoto. Yeah, this is correct. Satoshi Nakamoto. Yeah, so all of you are correct, those who have answered this. The founder of Bitcoin is Satoshi Nakamoto. And interestingly enough, nobody knows who that person is, or is it a group of people who started Bitcoin, or is it just one person? It is a mystery, and it is quite surprising that in such a day and age where everything is digital, how these people were able to kind of hide their identity on the internet. It's an interesting scenario or case. And do you know what Satoshis mean in the Bitcoin? In terms of Bitcoin, it is also a unit. It is smaller portions of Bitcoins are called Satoshis. So like we have rupees and paise. So paise is equivalent to a Satoshi. List 5 uses of blockchain for supply chain management. Improve tracking and transparency, better communication and collaboration. Okay, there are two examples there. Address food safety issues, promote ethical and sustainable sourcing. That's a good one. Make payments more efficient, better communication and collaboration. That is good. Streamline contracts, revolutionizing instant payment, sustainable procurement, ESG. Okay, so this you got from the slide deck that I had, so that's a good one. Improve tracking and transparency, food safety, ethical sourcing, payments, better communication and collaboration, safety, is new here? Tracking, transparency, safety, ethical and sustainable sourcing, smooth transaction, better communication. Okay, so all of you have got this correct. What is a hash? Hash is a function, data to fixed sized values. Okay, that's a good description. A hash is a mathematical function that converts an input of arbitrary length into an encrypted output of a fixed length. Doesn't have to be encrypted, can also be a non-encrypted text. But yeah, that's a good description. A hash is that can be used to map data of arbitrary size to fixed size values. Yeah, that is right. Yeah, here again, the same definition in the next one. Hash is an address that can be used to map the data. Okay, this is a different perspective of how you have got hash, because this is how it is actually used in a blockchain. Can be used as a way to map the location of a file, for example, on an IPFS network. All right. What is the content of a block? Data transactions. Okay. Each block contains a cryptographic hash of the previous block, a timestamp, and transaction data. Yeah, this is very clear explanation. Then each block contains a cryptographic hash of a previous block, a timestamp, and a transaction data. Again, yeah, a similar answer. Number 10. Set of data is very simple answer. But yeah, so basically the content of a block contains, it contains all this, but there's a lot of other things as well. But I haven't gone into the technical details of that. But at a very high level, this is correct. So it contains the previous block hash, timestamp, and the transaction, a collection of all the transactions or all the data that is stored on the block. What is the Genesis block? So this is fairly straightforward. Genesis block is the first block in the blockchain. And it's not just for Bitcoin. Any blockchain we typically use Genesis block to represent the first block in the blockchain. What is the smart contract and how does it work? Smart contracts are simply programs stored on a blockchain that run when predetermined conditions are met. Okay, that's a good answer. Smart contracts is simple programs, if else, if then. Yeah, that is what I mentioned in the lecture. So that's good. A Genesis block is the name given for the first block of the blockchain. That's also true. So yeah, so you got this correct. How does it work? Has anyone answered that? Smart contract. Smart contract is an agreement between peers to perform secure transaction. There is some explanation here. Smart contract, business rules implied by the contract embedded in the blockchain and executed with the transaction. Yeah, so this was from my slides that you have got this answer. This is also good. But basically, a smart contract is automated logic that is used to execute predefined logic for business process. For when you want to execute a business process in an automatic way, smart contracts are used. What is a dApp? DApp applications are digital applications or programs that exist and run on a blockchain network instead of simple computers. So DApp is basically a decentralized app. DApp stands for decentralized apps or decentralized applications. List some other applications of blockchain. Let's go from here. Money transfer, healthcare, personal identity, NFT, logistics. Yeah, these are all good examples of blockchain. Internet of Things, personal identity, healthcare, money transfer. Yeah. Internet of Things is also, I could say, as it's not an application of blockchain, but you can use it along with blockchain. Yeah. Internet of Things is a way to capture data, and blockchain is a way to store data. Identity management, financial application, healthcare, e-voting. Okay. Banking systems and voting systems. Okay. Yeah, so there are many other use cases of blockchain. So that you got a good answer there. Find the meaning of TPS for a blockchain. Transactions per second. Yeah, that is the answer. TPS stands for transactions per second. And different blockchains take different time to process the transactions that are there. What is gas in the context of Ethereum? Gas is basically a transaction fee that you have to pay to process or to put a transaction on a Ethereum blockchain, Ethereum network. Let me see what answers you've got here. Unit of measurement for computational work. Okay. A gas fee is a blockchain transaction fee paid to network validators for their services to the blockchain. Without the fees, there would be no incentive for anyone to stake their ethers and help secure the network. This fee is necessary to prevent spamming of the network. Yeah, this is a very good answer. Gas is incentive or blockchain transaction fee paid to network validators for their service to blockchain. Basically, it is a fee that is required to maintain the network and also to incentivize the people who are mining. If an attacker wanted to tamper a blockchain, what percentage of blocks would they need to alter? So this is fairly straightforward. 51% is the answer for this. So if 51% of blocks are modified or tampered, then a blockchain can be tampered, but that is practically not possible. List 3 benefits, key benefits of blockchain technology. Transparency, security, and decentralization. Okay. Immutability, traceability, collaboration. These are the actually features. Okay. The next question is list 3 key features of blockchain technology. So I think those were the answers to that. Key features: immutability, traceability, and collaboration are the 3 features. Which industry would you like to see the use of blockchain technology? This was just to see where you can, which other industries would be useful. Power grid, okay. So even what we mentioned earlier on, like personal identity, healthcare, logistics, and all the other areas are areas where we can use blockchain. So those were the answers to the tutorial questions. Do you have any questions other than this? And I have answered some of the questions that were asked in the chat. So do check those answers. What I will do is I will copy those answers to the Google Doc as well. So it will be there for on record for everyone. Maybe what I can do, I'll actually go through these answers just for everyone's understanding, and we also have enough time to review them. So these questions were asked by I cannot see the chat now, but okay. I will go to these questions first. The first question was where the initial transactions will start, from Genesis block or block 1. So all the blockchain transactions begin from the Genesis block, which is why it is called as the Genesis block, which is the first, first block. Okay. The next question was how many valid transactions can be stored on a block? So the answer to that is depends on the type of blockchain. For example, in Bitcoin, it is 1 MB. The size of the block is 1 MB. In Solana, it is 10 MB. So different blockchains have different sizes for that. In Ethereum, it is actually worked out based upon the gas fees. So it is roughly around 46 KB is the size of the block there. Next question was, what is the difference between cyber security and blockchain? So blockchain is a technology, like it's a new technology that we are learning today. Cyber security is a field of information security, right? And then there are a lot of things that can include that are part of cyber security. Yeah, so that is the difference. This is a technology, this is a field. This fourth question I could not understand. So if you can just elaborate that, then I probably can answer this clearly. In blockchain ledger, valid transactions only stored. How to find invalid transactions? So the answer to that is you cannot find invalid transaction. What most likely happens is transactions get invalid because you have not paid enough fees or there is not enough funds in your wallet to pay for the transaction, in which case the transaction is not processed. And the only way to figure out is when you see your wallet and then the funds will be returned to you. So that is a way to kind of figure out that the transaction did not proceed. Next one was, what is SHA-256 and consensus? SHA-256 is a hashing algorithm, to generate a hash. And consensus mechanism or algorithm is used to validate new blocks and add to the blockchain. So the whole the whole process that we kind of today we saw in the demo when we pressed the mine button and what all thing happened in the background was an example of consensus, because someone or the miner in a blockchain has to collect all the different blocks, all the different transactions and follow a way to agree upon the content of the block, and the one who generates the first, creates the first computes that first 4 zeros in that example, they are the one who win the right to create a new block, and for that then they are paid in the local currency of that blockchain. It could be Ether, it could be Bitcoin. What is nonce? Why hash value start with 4 zeros? What is the relationship between nonce and hash? So nonce, as I showed you in the demo, is used to generate a hash that begins with 4 zeros. Okay, so this is just an example criteria set by a hypothetical blockchain, right? So you can change that criteria and you can say the hash should begin with 4 ones, or 5 zeros. It is up to you. Basically, this criteria here makes it difficult to compute that number and hence prevents bad actors from attacking the blockchain. That is the main purpose. We keep changing the nonce till a point we reach the criteria that we have set for the blockchain, which is in that example that I gave, it was the hash should begin with 4 zeros. How transaction costs are reduced in a blockchain? So transaction cost has become a major concern because when blockchains became very busy, right, the cost of the processing a transaction became high just because of demand and supply. So to cater to that problem, layer 2 solutions came into picture, and layer 2 solutions such as, for example, Polygon is one example. And they are designed to reduce transaction costs, because what they do is, instead of sending one transaction to Ethereum and paying the Ethereum fee, you send a transaction to Polygon. And Polygon collects a lot of transactions and puts those transactions and generates a hash from that transaction and kind of puts that like one transaction on the Ethereum rather than all the 100 transactions. So that's how it kind of reduces the transaction fee. And it is also faster because the processing is much faster there. In a blockchain, hash, I don't understand this question, so I'll not answer this one. How will you validate or verify transaction? So when you are referring to a validation or verification of a transaction, this is where we are referring to how a block is created or verified. Okay, so in the blockchain demo that I showed you, we used nonce and a text to generate a hash starting with 4 zeros, right? So that was a criteria. So a transaction is valid when it meets this requirement. Hence, we are referring to the transaction to create a new block and to add the block to the blockchain network. So in case of, say, like Bitcoin, the miner have to solve a problem like this, right? And the one who solves this problem is the one who is considered to have verified or validated the transaction to create a block and add it to the blockchain. And for that, they give Bitcoin in the Bitcoin network. You receive Bitcoin for creating a new transaction. But that process becomes so complicated now that it, like you and me, just with our computers, cannot create. They do not have enough capacity or processing power to execute the proof of work. Or basically to find out that hash, that four zeros, to find out that nonce. So big companies now use big data centers to solve this equation, and this has actually created a lot of issues among environmentalists because they think that it is too much waste of resources, and which in fact it is. But now to respond to that, these data centers are now going green by putting generating the energy required for these computations using solar panels. So there is some work that's happening there. And the last question was suggest research needs for blockchain. So I think I will cover this in the future sessions, so we can keep it for that point. Okay, so I hope this was helpful for you all today. If there are any other questions, maybe you can ask them now. We still have some time. If not, you can always list any questions in our Q&A Google Doc, and I can answer them for you there as well. How to verify the smart contract is correct? Okay, so this is a problem, and one thing that is adopted in the in the blockchain community, or the blockchain best practices, is to have the smart contract audited by a third party. So there are companies who do smart contract auditing, and their job is to look at the smart contract code that you have developed, and make sure that it performs or it functions the way you intend it to function. Okay, so that is one way to verify the smart contract. The other thing that we typically do as a best practice is, when we build a blockchain solution or a network, we keep it in the test net. And test net means like a test network. And this is the time to actually assess the functionality of your smart contract. If the smart contract behaves in an unreasonable way, or some logic is wrong, then you have the time to amend your smart contract before you put it on the live mainnet. So that is the two approaches I would suggest for verifying the smart contract. What are all the platforms there to write smart contracts? Smart contracts you can write in any development environment, and then you can push it to the to respective chain. For example, in for Ethereum, you can write it in Solidity, in their own Solidity development environment, and you can test it and upload it when you are ready. It's following the same process like I explained, that you put it on the test network first, and then you take it to the live net, a mainnet. Okay, so if we don't have any further questions, we can conclude today's session. I would suggest you review all the slides that I have covered today, because it is for most of you, it is new technology that you are getting exposed to for the first time. So there may be some questions that you may have now or in the tomorrow. Then do come up with a list of questions that you have, and I'll try to answer them. Tomorrow we will go a bit more detailed into different supply chain applications for with blockchain. And I will show you one blockchain as a service platform that we have developed. And if time permits, maybe in the tutorial, we can actually run the program, and you can be able to post some transactions on Polygon network, testnet. Okay, so we will do that tomorrow. So there'll be some little bit more of a activity, hands-on experience that you will get as well. Okay, so let's finish and do review the slide deck slides before tomorrow's session. All right, thank you all very much, and have a good rest of the afternoon.
Thank you, sir.
Thank you, madam.
I like to thank the Professor Dr. Vidyasagar Poddar for today's session on blockchain and today's tutorial session. It was very nice, interesting, and this session was, I hope this session was interesting for all the participants, and all the participants have enjoyed. I like to thank all the participants for their active participation in their tutorial session as well as in the lecture sessions. Thank you, sir. And thank you all the participants.
Thank you all. See you tomorrow.
Yeah, thank you, sir.
Bye.